So we'll begin to deal here. By the way, we really best first search for the GBFS implementation. So as what we have deal earlier in the previous video, that the basis that you'll begin to deal here in your F of n will become close to the H of n, or that is the estimated um cost from the initial state, from the state, from the initial state to goal state. So that will be the HL. Now, we're going to see that later as we go on the process. In your step one, you will consider within um, the first, since what is your initial state? That is A. So therefore, supposedly you will insert that in your Q, right? So the adjacency of A, adjacency of A. So you'll begin to step by step the process go in this particular case. But let me okay. So since we are using the priority queue in this case, that's what we have stated that we're I'll be going to reinstate everything. I'll be going to change everything that what we have done um your because this one in our discussion. I'll be going to do that step by step, of course. So in your step one, you will be going to insert in in your particular. I want you to really deal with a particular as well. So given that the f of n, I mean f of a, that is h of a. So your h of a, that is 10. Diba? So I don't know. That is equals to 10. So therefore, we will insert that in your Q. A, then in Q, A. So you will do. So what will be the second step? So we will be going to check this A right now. What is the adjacency of A? Now then, you will be going to um calculate each of the f of n for that one, step by step the same thing, and you will choose what will be the preferred or the lowest, and then you will remove that in a queue. That's what we have deal in the description. Okay, so the adjacency of A, that is B, that is C, and D. What will happen right now? You will identify the f of B, identify f of C, identify f of D. What will be f of D? That is letter BC. Yeah, f of B is 4. Definitely back. And f of C, that is 17. And f of D, that is 13. Don't forget to insert that in your Q. Insert B in Q, B, then A, B, C, in Q, C, and A, B, C, D, in Q, D. So that's how it works. Because you have the step by step the process is what I have said. I just want you to deal everything. And afterwards, you will begin to check what will be the lowest element or lowest value of the h of n? Is it B, C, D? So with this h of the f of n that we have right there is the f of D, f of B. Choose, sorry, around, choose f of B. Then remove that in the queue. Since that is priority queue, that is low priority. So what will happen in your queue? It will become A, C, D. That's how it look like right now. Looks like right now. In queue. In queue. Oh, no. That's not in queue. DQ. B. And then check as well. Does B is that equal to your goal, which is N? No. So we'll continue the process. So that's how it works in a step-by-step manner. Since you're able to visit the extract that letter B already, and we're able to search that, and that's not the goal state right now. So we'll be going to proceed with the third step. In the third step, class, you will be going to continue. What will be those extracted data? You will be going to visit their adjacency. What is the adjacency of B? That is, sorry. So B is somewhat, this is undirected graph, so that is connected to A and E. So A and E. So therefore, the F of A and F of E right now. So F of A, the H of A, that is 10. And F of E, that is 12. So technically, what will happen? You will be going to put here already export. Because you cannot remove, you cannot be going to definitely what do you call this one? By the way, priority already earlier. Yeah, that's correct. So let me just go ahead and um we were able to forgot to the queue name A in our array in our queue. So let me just correct everything. So afterwards here, the queue A. Because you will remove that in B since there is no other, that is the start node. So the queue A that is empty right now. So what will happen? A is not here already. A is not here. A is not here anymore, and A is not here anymore. So that's the updated. So make sure to, I almost forgot that one. So better that we're able to have it here. So F of E, that is 12. So since A is already expired, there's no need for you to enqueue that one. Since you just have to put that there already expired. So since this is not visited yet, so you will be going to enqueue that. Since you will enqueue at only in the rear end, so enqueue in, it will become CDE, and then enqueue E. That's how it works. And then what can we choose in the one? So there's no other chance that we can choose A. but we can choose E right now because that is the unvisited element that you will begin to take with. Choose E, then you're updated. You will remove E right now in your priority queue because that is the low priority. What will happen? The Q, E. So then we will compare, does E, by the way, here again, you are not able to, does A, is it equals to L? No. And does E, is it equals to L? No, the same thing. That's how you will deal with that. Now, in your step 4, your basis, the adjacency of E, of E. What is the adjacency of E? So checking that one, that is letter B, letter C, letter HI. So BCHI. BCHI. So therefore the F of B, F of C, F of H, F of I. By the way, I want you to definitely identify if that was visited or not. FB was absolutely visited already, right? In your queue earlier. So we were able to visit that. So F of B, that is technically 4. Then F of C, that is 17. F of H, that is 21. F of I, that is 2. Now, F of B was already included earlier, already visited. So, only already explored, but somewhat, I don't know, the same with their visited. Then afterwards, F of C, or since C is already in your queue, so already explored. So that is still the same thing because C is already in the queue. So there's no make sense that you will begin to put the same thing that you will begin to insert again that is no, that's not gonna happen. So already explored, only state already explored, okay? So F of H, the F of H is 21. So insert that in your queue. So your queue right now is C, D, and H. Then in Q, H. Now I, C, D, H, I. In Q, I. By the way, I want you to really start from the lowest element up until the highest element with the adjacency. I want you to really make sure that it is sorted accordingly so that we could be able to have the same answer, especially in the Q as well. I don't want you to interchange CB, HI. I don't want you to CB, IH. No, no, no. Please make sure to have it in a certain manner as well. Now, what can we choose? Choose 2, which is I. Now, choosing 2, your Q will become CDH. So, that is the low priority. Now, the Q, I. So, what will happen? I is it equals to L? No. So, what will happen? You have to check what will be the adjacency of I in your step 5. Adjacency of I. What is the adjacency of I? That is H, J, H and J, and E, F, G. So that is no, E, F, G, H, J. Take note. So E, F, G, E, F, G, tapos H and J. H and J. So what will gonna happen right now? F of E, F of, sorry, F of E, F of F, F of everything. We will need to basically mention everything. F of E, then F of F, F of G, F of H, F of J. Okay. F of E, what is the value of F of E? That is 12. So 12, 9, 18. 12, 9, 18. Then H and J, 21 and 5. 21, sorry, 21 and 5. So this will be the implementation. So now you will assess. So you're curious now. Are we able to insert E earlier? Yes. So since E was already inserted earlier, already um well that explored, then F of F, let me check if that was visited already earlier. F of F, A, B, C, A, B, D, A, E, B, C, H, I. No, not yet. So what will happen? C, D, H, F, where you're able to in Q, F, 9. Then what about G? Straight to C. I, H, C, B, A, E, A, D, C, B. So there's no H right here, there. So, ano, G, what I mean, diba? Wala pa si G na insert earlier because, yeah, that was clear. Okay, so C, D, H, F, and G. And in Q, letter G. And in your H is already explored, since that is still in the Q zone. So what about J? What is J? A, B, C, D, A, E, B, C, H, I. So not yet in the Q, was not explored. C, D, H, F, G, J. Now in Q, J. What will gonna happen? Now what will be the thing that we can choose? Choose. Is it 5? Is it, we cannot choose 21 anymore because that was very earlier, no? Okay, you only choose 9, 8, 5, 8, and 5. So choose J. I don't know, you can only matter here in this. So choose J. And what will happen? Remove J. So that is 5. So C, D, H, F, G. So the Q, J. What will happen? This J is equals to L. No. So proceed with step 6 and adjacent of J is, what is the adjacency of J here? To J, that is GIKL. So GIKL, GIKL. So the F of G, F of I, F of K, F of L. Now, does, what is the, that is 18 to 22, 0. 18 to 22, 0. I've actually put 0 right there so that that's don't matter. I've actually been more to with that. Now here, f of g is still on queue already explored. Already in the queue. So f of I, let me check if we were able to insert it earlier. Yeah, we inserted that one, so it already explored. So what about king? We inserted it J H G F E I H C B A E D C B A. No, not yet. So we can insert that in the queue. So what will happen here to C D H F G and king. So in Q king. Now what about L? Not yet, because we were not able to insert it earlier. CDH, F, G, K, L, and in Q, L. Now, what can we choose? Is it among the element here? So that is it G? I don't know, is it G, I, 22, 0? So given the fact that 0 is much more good, so I can definitely choose that one. So since that is the full state, to choose and then what happens C D H F G K and D Q L. And then what will happen? Does L is equals to L? Yes. So therefore it's found already. So that's the case that you'll be going to implement in this case. So that's how you will calculate the really best first search. That's how you will be able to implement that one. So we're done with that, and I'll be going to talk a little about the another searching algorithms in the next video. Thank you so much, and see you again.